Okay, so we've got a curve, and we want to know when the tangent is parallel to the x-axis. So parallel to the x-axis means that the dy by dx, the slope of that curve, has to equal 0. Okay, so how do I work out dy by dx for this? Well, I haven't got y in terms of x, this is implicit differentiation. So I'm going to differentiate every term with respect to x. So, differentiating the first term, the 2x, that's going to differentiate to 2. And then I've got to differentiate x squared y. Now that's a product. This is x squared times y. So product rule, I need a u of x squared and a v of y, so that my u dashed is differentiate x squared, it's just 2x. V dashed, well, differentiate y, you might think that's 1, but remember it's with respect to x we need, so we need to multiply by dy by dx. Okay, so yes, of course, when I differentiate y, I get dy by dx. So I need to do u dashed v, 2x times y, 2xy plus uv dashed, which is x squared times dy by dx. So I've got as far as here, and now I need to differentiate this minus 2y squared. Minus 2y, oh, but that was using y's, so I have to multiply by the dy by dx, equals 0. Now at this point we can find dy by dx if we want to. We can get the dy by dx terms on one side, the other terms on the other side. We can do dy by dx times a bracket equals some other stuff and then divide by the bracket. But you know what? I don't actually have to do that this time. Okay, because I'm just interested in finding a point where dy by dx is 0, I might as well just solve dy by dx equals 0. So I need to have got all the terms correct here, but now taking dy by dx equals 0, I can just say that 2 plus 2xy plus 0 equals 0. And that rearranges to 2xy equals minus 2, so xy is minus 1. So that means that y is going to equal minus 1 over x. Well, how does that help? Okay, I want to find x and y, and this doesn't tell me x and y, but I already know a connection between x and y, which is this is the equation of the curve. So I can substitute my y in terms of x into this equation and see what I get. So if I do that, so if we do, what we're doing is we're subbing into the curve, and I've got 2x, leave that as 2x, plus x squared times y, but my y is minus 1 over x. Minus y squared, but my y is minus 1 over x, so I'm squaring that, equals 0. So this is an equation that I can hope to solve in x. X squared times minus 1 over x, well, x squared divided by x is just x. So this is 2x minus x. Now this thing here, squaring the minus makes this minus vanish, but I've still got the first minus. And then I've got 1 over x being squared, so that's minus 1 over x squared. This equals 0. So adding the 1 over x squared to each side and simplifying this bit, this is just x. So that gives me that x equals 1 over x squared, which if I multiply by x squared gives me that x cubed is 1. So I can find x by cube rooting, and because it's a cube root there is only that one answer, so the cube root of 1 is just 1, and y I know is minus 1 over x, so that means y is minus 1 over 1, which is minus 1, so my point is 1 minus 1. I only get 1 point, which is good because looking back at the question it's fairly specific that there should only be 1 point. Okay, so we found it and there's our method. Excellent.